Dear students, last class I told how to detect the pH by using the SHE, and on today I will go for the discuss about the relation of oxidation potential or reduction potential with the concentration of ion. So let's say I am taking one of the electrode, reference electrode is SHE, and I am taking this SHE as cathode. And let's say I am taking a metal in which oxidation takes place, and this metal M undergoes oxidation, so M is converted to Mn plus, and we are giving a salt bridge. Now in the left hand side we are using the SHE as a cathode, and this is a reference electrode, and we know the potential value of SHE, either it is cathode or anode, its potential value is always 0. Now if I want to write its equation for the anode, what will be its equation? Its equation will be M give rise Mn plus n number of electrons, because this is the oxidation part. And for the cathode, as its reduction potential value as well as the oxidation potential value is 0, so it is not necessary to write its equation. If I am to write, then what will be the cathode reaction? The cathode reaction will be, that is the 2H plus 2 electron is converted to H2, that is the hydrogen gas, and it is under the, that is your reference electrode SHE. Now if I want to calculate the cell potential value of it, I can write what is E cell. I can write E cell is equal to, that is E oxidation potential at anode plus E reduction potential at cathode, and that can be written as, that is your E oxidation potential at anode, and at anode the reaction which is going on is M is converted to Mn plus, so I can write that is your E M is converted to Mn plus E reduction potential of cathode, so I can write that is your E of reduction potential of standard hydrogen electrode, and this reduction potential value of standard hydrogen electrode is 0, so I can write that is your E of M to Mn plus, and this value is 0, so that is your E of M to Mn plus, and that is the E cell is equal to, we are getting E M to Mn plus. E cell is equal to E M to Mn plus. Let's say this is the equation number 1. Now I want to go for the calculation of oxidation potential value of anode. So when I will go for the calculation of oxidation potential value of anode, what can I write? I can write now, that is E of M to Mn plus is equal to E naught of M to Mn plus minus 0.059 by N, because here the number of electron in the oxidation part I have written N into log, and what is the Q value? Log Q, and this Q value what can I write, as I have written the equation is M is converted to Mn plus N electron, so here N is number of electron is N, and what is the Q value? Q is your concentration of Mn plus divided by concentration of M, and this metal is a pure solid, so I can take its concentration tends to 1. So if I want to take its concentration tends to 1, so that implies I can write that is your concentration of Mn plus. So here I can write this is equal to E naught of M to Mn plus minus 0.059 by N into log concentration of Mn plus. So we are getting this is your E of M to Mn plus, and which is taking place at anode, so that implies I can write that is nothing but is your E oxidation potential at anode. So now if I want to write this equation here, what is the equation 1? The equation 1 is your E cell is equal to E M to Mn plus, so I can write this equation can also be written as E of M to Mn plus, that is nothing but is equal to E cell from the equation 1 is equal to E naught cell, is equal to E naught M to Mn plus minus 0.059 by N into log Mn plus. So let's say I want to plot a graph by using this, and here I want to put this equation as equal to y is equal to mx plus c So here I will take, this is the oxidation part of this reaction along the y-axis, and I will take, this is the constant standard oxidation potential value, so this is, let's say, C, and here this will be the slope, minus 0.059 will be the slope, that is, let's say, X, then that is, let's say, slope is M, then log Mn plus is your x-axis. So I will take, this is in x-axis. So if I want to plot a curve by using y is equal to mx plus c equation, so here I am taking, along the y-axis I will take E of oxidation potential, and along, this is the oxidation potential, and along the x-axis I will take log Mn plus, so that is the concentration of ion. Then what is the slope? Slope is coming negative, where the y-intercept is E naught of M to Mn plus. As the slope is negative, so it moves downward, so you will get this value will be a slope value, and this value is your minus 0.059 by N, and this is equal to your slope, and this is the y-intercept, that is called C, and this is your E naught of, that is oxidation potential, that is oxidation potential of E naught. So what is the conclusion we are getting here? We are getting, the conclusion is that oxidation potential and concentration of ion are inversely proportional, because on increasing the oxidation potential, the concentration of ion decreases. So I can say the oxidation potential is inversely proportional to the concentration of ion. Is it? So this is the, we are getting the relation between the oxidation potential and concentration of ion by plotting a curve using SHE as cathode. On the same way, let's say I want to find out what will be the relation between the concentration of ion and the reduction potential. So if I want to go to find the relation between the concentration of ion and the reduction potential, then I will use SHE as a knot. Let's say I will use SHE as a knot. So now I will write here, on the left hand side I am using the SHE and then a salt bridge. Then let's say I am taking a metal which undergoes reduction on the right hand side, so this is act as cathode. Now if I want to find out the reaction at cathode, what can I write? The cathode reaction is your reduction reaction here. So here Mn plus is converted to M. So I will balance by adding n electron in the left hand side. So here what is the Q? Q is your concentration of M by concentration of Mn plus, and this M can be tends to 1 because it is a pure solid, so that is your 1 by concentration of Mn plus, I can write. So that is equal to, I can write, that is your concentration of Mn plus to the power minus 1. So now what will be the E cell value? Now what will be the E cell value for it? I can write what is E cell. E cell is equal to E oxidation potential at anode plus E reduction potential at cathode. So here what is the anode? Anode is your SHE, so I can write that is your E oxidation potential of SHE plus E reduction potential. And what is the reduction potential here? Mn plus is converted to M, so I can write that is the E reduction potential, which is Mn plus is converted to M. And we know the SHE is a reference electrode and its oxidation potential as well as reduction potential is equal to 0. So I can write that is your 0 plus E of Mn plus slash M. So here we are getting the equation, that is E cell is equal to E of Mn plus to M. So again, let's say this is the equation number 1. So here I want to again put the Nernst equation. So if I want to put the Nernst equation here, then I can write what is the Nernst equation for the reduction of cathode. I can write E of Mn plus to M is equal to E naught of Mn plus to M, that is minus 0.059 by number of electron I have written, this is n into log q. And what is the q value? That is your mn plus to the power minus 1. Now I can write this is your E of mn plus to m. This is nothing what is your E cell according to the equation 1. So if I want to write this is E cell, this is nothing but is your E of mn plus to m, and this is nothing but is your E reduction potential of cathode is equal to E naught mn plus to m, and this can be written as plus 0.059 by n into log concentration of mn plus. So that can be written as plus 0.059 by n into log concentration of mn plus. So here again I want to find the relation between the reduction with the concentration. So for that reason I will plot a graph. Here I will take this is along the y-axis. Let's say I will take this is along the y-axis. So this will be along the x-axis. I will take this is along the x-axis. So this will be slope, and here the slope is positive. So this is m, and this is your y-intercept. This is a constant value. So this is, let's say, c. So we are getting again the same equation, y is equal to mx plus c, but here we are getting the slope is positive. So if I want to plot a curve or graph for it by taking log mn plus along the x-axis, so we are taking log mn plus along the x-axis and E of mn plus to m, so that is the reduction potential. So we are taking E of reduction potential along the y-axis, and we are getting a slope that is a positive slope, that is 0.059 by n. So as the slope is positive, so it moves upward, and its slope value is 0.059 by n. So this is your slope. And what is y-intercept? Y-intercept is this one, and its value is your E naught of mn plus to m. Now we are getting a relation between the reduction potential and concentration of ion. As the concentration of ion increases, so we are getting at cathode the reduction potential is also increases. So that indicates the concentration of ion is directly proportional to reduction potential. So concentration of ion is directly proportional to reduction potential. So here we are getting the two things, that is the oxidation potential is inversely proportional to concentration of ion, and the reduction potential is directly proportional to concentration of ion. On the next class I will tell about the secondary reference electrode, that is the calomel electrode.